Knox Game Design. August 2022. Logo.
Welcome everyone to Knox Game Design for August 2022. My name is Levi Smith. So this month we're going to be talking about Logo. So Logo is actually a development programming language primarily geared towards like learning and teaching. A language I've never used before until this month, but I've heard a lot about it and kind of knew a little bit about it from what I've heard in the past. So just an overview of Logo. It was created a long time ago, 1967. It's considered to be in the Lisp family of languages, a functional type language, and it introduced this concept of what's called turtle graphics. So you got a screen, and you got a little cursor, you can move it around, called the turtle. Now, in the environment we'll be looking at, it doesn't actually appear as a turtle. So the version of Logo that I'm going to be using is called Berkeley Logo, and there are other flavors of Logo out there, but this Berkeley Logo is free to download and use and everything. So this is the interface right here. You just download it from the website. It's free. So the basic concept is you have this turtle that you move around, which appears as a triangle. So you can have multiple ways of interacting with this turtle. Like you can move him forward or backwards. You can turn him a certain number of degrees. Like if you want to make a right turn, you can do right 90. If you want to do left turn, you can do left 90. And you also can specify whether as the turtle moves around, whether it's actually drawing a path with pin down or not drawing a path with pin up. And also you can manually set, if you don't want to like go to a direction relative to the current direction, you can just set the absolute direction that the turtle is moving using this set direction, set age. So here it is. I'll work through these examples right here. So if you want to move the turtle starts in the middle of the screen. So if you want to move him forward 100, just do that. You can see he moved from the center of the screen up 100 pixels. Unfortunately, there's not a way to magnify this. I got my little Windows magnifier over here to make it a little bit bigger. If we want to make a right turn, we can do right 90. Right 90. That's going to move the turtle. He's going to point him going to the right. There. You can also do like FD 100. That'll also do forward. So they do have like shortcut notation. And I believe right is RT 90. That's going to move him 90 degrees from his previous position, so now he's pointed downward. Now we're going to do forward 100 again, then right 90, then forward 100. So that just made a square using the turtle graphics right there. Want to do a triangle? And actually, I'll talk about it in a minute, but we can clear the screen using clear screen and hide the turtle with hide turtle. So let's do a clear screen. Walk through this second example. So we want to do forward 100, forward 100, and we'll do a right turn 120 degrees. So we get 120 degrees. Because all of the angles and I believe a triangle, it adds up to 360. So 360 divided by 3. That's right. Yeah, it is kind of hard to do math on the fly while you're giving a presentation. So let's do another forward 100. Then let's do a right turn of 120. And do forward again 100. So that gives us our triangle. So yeah, this is a game design presentation, but this is more geared toward just like teaching people who aren't familiar with programming, how to like make basic shapes, and but I will in a later slide show that it is possible to make a game using Logo, and there's also other platforms, Logo similar platforms or derived from Logo, where you can actually make real-time games, which is pretty cool. So yeah, I kind of mentioned this before. The default center 0, 0. It doesn't use like the screen coordinates, so it goes from X left to right, negative to positive, and Y goes from bottom to top, negative to positive. So it's more like natural coordinates than the screen coordinates, traditional screen coordinates. And yeah, as I mentioned, clear to screen with clear screen. You can also do hide turtle. That's gonna make your turtle go away. Or I think the opposite is show turtle. Show turtle. Hide turtle. So if you got your drawing done and you want to show it off, you don't want the little triangle on there, cursor, and use it, just hide turtle. Okay, so now we got a simple drawing, just black and white, but black and white isn't very interesting. So they do have ways to change drawing attributes, such as the color of the line that you're drawing, which is set by set pin color. You can either specify one of the predefined constant integers, or you can set pin color RGB. You can also set the drawing size with set pin size and specify the color. So right here I have an example of showing 4 different colored lines. Here's the small Logo program right there. So let's go ahead and we'll go ahead and do show turtle, then clear green. So I'm going to do set pin color 1. So that's going to set it to blue. So you can see our turtle now is blue. And we're going to set pin size to 1, just to reset it to 1 pixel. Then, so here's a way you can do a loop in Logo. So repeat 7 times. So we're going to move forward 50, set pin color plus 1. So for 1 through 7 or 1 through 8, it's going to go 50 pixels. And then after it goes 50 pixels, it's going to go to the next color. And then draw another 50 pixels. And then change to the next color. So you can see it changes colors every 50 pixels. Like I said, you can also specify RGB values, red, green, blue. Set pin color to 100, 0, 50. That'll do right 90, forward 200. So yeah, there's like a pink rose colored line, 100, 0, 50. So yeah, the range goes from 0 to 100, not 255. So full red is 100, 0 green, and then half blue. So here's the color values over here. It's a lot like if you watch the QBasic presentation, it's the same QBasic, the values they use in QBasic. And you can derive those from the RGB values. So you got 000 is black, 001 is blue because 0 red, 0 green, 1 blue is blue. 010 is 2, that's 2 in binary. So that's green, no red, all green, no blue. And then 011 is 3 in binary. So there's our 3. So that's no red, all green, all blue, which is cyan. Then 100 is 4 in binary, so it's all red, no green, no blue. 101 is 5 in binary, or 101 is binary for decimal 5, which is magenta. Some people say hot pink. So that's all red, no green, all blue. 110 in binary is 6 in decimal. It's all red, all green, no blue, which is yellow. And then 111 is all red, all green, all blue, which is binary for the decimal value 7. And that's white, all on. And then they have some other predefined values like brown, tan, forest, aqua, salmon, purple, orange, and gray. These do not follow that RGB convention. They're just kind of predefined constants. So you can also use those. Yeah, I should have increased the pen size for that demo. Let's see here. Clear screen. We want to do right turn 90. Set pen size. Just set it to 8. It makes the turtle really, really big. And next you can press up to go to your previous statements. So set pen color to 1. Then repeat 7 times. Forward 50, set pen color plus 1, so that we get the big, bold, blue, green, cyan, red, magenta, yellow, and white. If you wanted orange, you'd do like all red, half green, no blue. So it doesn't follow the traditional Roy G. Biv color spectrum. So in Logo, you can also define variables. So this is where you can start getting into actually making a program instead of just drawing. So you use make, then you do double quotes, your variable name, and the value. So the example here is make secret number 42, and then print secret number. Make secret number. You gotta do the double quote before. With the double quote right there. Make secret number 42. And print. And to print it out, you got to do a colon before your variable name. Print secret number. Secret number. That prints out a 42 right there. So it's kind of like dynamically typed. You can either assign numbers or strings right there. I think there may be some casting or convert string values to int value. Yeah, we also have, so if you want a random number, you can just use the random command. And like I said, this is functional, so you just print all your commands in a list and it kind of starts processing right to left, I believe. So it gets to the far left. You can also like put brackets and parens around some of these if you need to group. Clear screen. Make secret number random 100 plus 1. Make secret number random 100 plus 1. Now we want to print secret secret number. So print to 15. So now if we do print secret number again, that's still going to print 15. But if we need to change the secret number, we just use that make command again. So that just made a new secret number. Then we can print the new secret number. So now it's 56. Yeah, this is just another example. Make 1, 2, 3, and make 4, 5, 6. Yeah, pretty basic stuff. So if you need to read input, you can use the let's see here, read word or RW. Oh, I have print there. Oh, So this is basically saying print, read, word right there. So first it's going to read word, read input from the command line. Then it's going to print out what you type. I'm going to type in hello. That's going to print hello. Do make num guess read word, say 42 or whatever. Then print num guess. That'll print what we input right there. That's basic input. Control, we have like our standard if the condition, then do the true. We have an if condition, then in the first square brackets we put true, the true result, then another set of square brackets, the false result. And we also have a while loop, while condition, then the true action. As we used earlier, there's also a repeat as well. So here's like a simple program. I'll try to pull this. Yeah, unfortunately in this Berkeley logo, it's kind of hard to work with the window. Let me get this command. While, then we're going to use a variable called I is less than 10. Then we're going to print I make I equal to I plus 1. I guess we should really like set I before we start. Yeah, so I has no value in while. So really what we need to do is make I 0. So yeah, just made I 0. Now let's try running this. Yeah, so there we go. We got, it's only showing like the last 4. But if we scroll up, see it started 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then once I got to 10, then it stopped. So I have some other example. I'm not going to run these, but yeah, if number guess 50, then press true. So it enters true. If number guess is 25, print true. If else number guess equals 50, then print true, or else print false. Then if else number guess is 42, print true, or else false. Kind of what we just did there. So I mentioned random numbers earlier. So you just do random, then your int value. So that gives you a random value 0 to n exclusive. So if we want a die roll from 1 to 6, then we're going to do random 6 plus 1. So because random 6 will give you 0 to 5. So then we want to add 1 to that to give you 1 to 6. So random, print random. Six plus 1. That gave us a 1, run it again, gave us 4, run it again, gave us 2, 2, 1, 0. Interesting. I don't think it should have gave us a 0 there. Have to look into that one. 4, 5. 4, 5. Yeah, maybe this. Maybe this needs to be in. Yeah, that's the problem right there. So basically that's doing 6 plus 1 to 7. So that's giving us a random value 0 to 6. So yeah, that's a mistake in my slide there. Yep, so that's working now. So yeah, that should have been random parens. Do the 6 plus 1 first because we're evaluating right to left. So do 6 plus 1 first. Or no, do random 6 first, then add 1. So we got 1 plus random 6. We can also do a random number, print random 100. That's going to give us a random value 0 to 99. like that. I'll put on the slide over here, random int 0 to 99. And int is just a whole number. So here's the number guessing game. I'm going to see if I have number guessing game. Because I don't want to type all this in. Yeah, here it is. Copy that. I'm just going to paste all that in. It is nice you can paste. So that's the program right here. So we're going to make a number guess. -1. We're just going to set it to an invalid value. Make number secret random 100 plus 1. So really that should have been random 100 plus 1, because this will actually give us a value from 0 to 100. So yeah, I need to go back and add parens around random 100 right there. Make num guess count 0, number of guesses. So while number guessed does not equal the secret number, then we're going to set the value of num guessed to whatever the user inputs. We're going to print out what the user inputted. That's a word. We're going to make number guess count. We're just going to increase the number guess count by 1. Then if the number guess is greater than the secret number, we're going to print lower because you guessed too high. We're going to tell the user to guess lower. If the number guess is less than the secret number, then we're going to print higher. You guessed too low, so we're going to tell the user to guess higher. Then if the number guess equals the secret number, then we're going to print correct, and then how many times it took you to guess the number. So here I have an example output. Enter 50, lower, 25, lower, higher, 37, higher, 43, higher, 46, and it took 5 guesses. So I'm going to hopefully run this. Uh-oh. Can't see enough. Oh, so it's waiting for my input right here. So it ran the program. I'm going to guess 50. Let's tell me lower. I'm going to guess 25. Higher. Let's do 37. Lower. Let's do 31. Lower. Let's do 29. Lower. I forgot what. I think I did 25. So 27. Correct. Took 6 guesses. I guess we can verify by print. What was it? Num secret. Num secret. Yeah, so 27. So just to verify, that was the secret value right there. So that's the basic number guessing game that I usually do in all my demos. You can also define procedures. So if we want to make a square, we can just say 2 square, repeat 4, forward 50, right 90, end. So let's go. We're going to say 2 square, repeat 4, and I'm going to use the shortcut F notation, FD 50, RT 90. Then we just do end to end that function. So now we just say square. So it's going to use whatever current properties that are currently defined for the pen. So we can do set pen size to 2. So it's all one word, set pen size to 2. And like set pen color to 4, that'll make it red. And let's do pen up. Let's do forward 200. Do pen down. So now we're right here. We're going to do square right there. Run that. So that gives us our square. We can do clear screen. Then we could do like a right turn, like 45 degrees. Then now our turtle's pointed that way. So if we do square, it's going to do a square relative to that location. Do hide turtle. That gives us kind of like a diamond. It's still a square, it's just rotated. So I have some other examples here. So I took the time and defined a star right here. I guess it isn't too complex right there. It's going to do clear screen, then 2 star size. So we're actually setting the size of the star. Then repeat 5 forward size, left turn 72 forward size, right turn 144. So the angle sizes are constant, but the size can be variable. Then do end. Then let's do set pen color to 2. Now it's green. So now we're just going to do star. Oh, so we've got to do star and then the size of the star. So we can do star. Let's do star 20. There's our star right there. You hide turtle. Hide turtle. So there's our star right there. So we can do clear screen. And here's the second example I have. So we want to got our X0 pin down. So we want to do star 20 pin up, set X 80 pin down. So there's our first star. And we do a star 40 pin up, set X 200 pin down. That gives us a little bit bigger star. Then we do star 80. Star 80 pin up, and HT is hide turtle. And now we got 3 stars. So that just shows how you can make things easier using like a function or procedure, whatever they call it in Logo, to redo common sections of code. So if you actually want to fill an area, here's the command you call filled, and pass it the values you want to fill. So here's a green, clear. CS works for clear screen. Here's a green, so filled 2, because 2 is green. A filled green square, so forward 100, right turn 90, forward 100, right turn 90, forward 100, right turn 90, forward 100. That might be one extra too many. But yeah, there's our green square. Actually, you can do set pen color, say to make it red, or then run the same field. So that gives us a square. It should have been a red outline. I don't know why that's a little bit off right there. Clear screen. So, yeah, there we go. So that gives a green square with a red outline. So you just got to set pen color to red before you start that filled command. So let's do set pen color to 7, set it to white, clear screen. Now here's a pentagon. 5 sides. We want to do filled for. So here's where we can do the repeat. Repeat 5 times. And then forward 50, right turn 72. So you just take 360 and divide by 5. That gives us the pentagon. 5 sides, equal length. So clear screen. Filled 1. So we're going to do a repeat 6. Forward 50, right turn 60. So actually you could write a function to do an inside polygon. So there's a hexagon, 6 sides, filled with color 1, which is blue. So here's an example showing the Tennessee flag. Took me a little while to figure this one out. See, okay, so there's the Tennessee flag with the 3 stars rotated, and the blue with on the red background, blue circle with a white outline on a red background with a white and blue bar on the right side. So yeah, I mean that you can do kind of cool stuff like that with a simple logo program. Here's the actual code over here. So we're just setting pin color for drawing the red background, then we're drawing the white bar and then the blue bar. Then we are going in here and drawing a circle. This is how you draw a circle. Repeat 90 times, and we just kind of keep going around. Yeah, there is no. So I think some versions of logo actually have a circle command, but Berkeley logo doesn't. So you just have to do this. Basically, you're creating a 90-sided polygon, which pretty much looks like a circle. So that's how you draw a circle. So now we're setting pin color to white. And then this is actually drawing the stars right here. The stars with 5 points right there. So yeah, I thought that was pretty cool. And last on, I want to show the snap thing. So yeah, so this is snap. A lot of different demo projects out here, and I think you can just like click run snap without even logging in. You can get to their interface. So it's a lot like Scratch, kind of based on the same engine, I suppose. You got variables, operators, and I think you can actually do like real-time games with this. Here's your area up here, your drawing area. So let's just do a simple simple square in purple. So I think it's control. So when the green flag is basically start. When the green flag is clicked, pin, we want to do pin down, make sure the pin is down. Then you can go over to control, then do our repeat. Yeah, so here's repeat right here. So you just drag these little blocks in, and they snap together kind of like Legos. So then motion, you can move 50 steps. So basically a step is a pixel. And then we want to turn 90 degrees. So yeah, we press our green flag. Oh, it didn't pin down. Oh, I used pin up instead of pin down. I was like, what's going on there? So let's get pin down. Put pin down in there and get rid of pin up. Pull those apart. Just delete pin up. Press the green flag. So there's our square right there. And you could do a set pin color too. Pick the pin color, make it like red or something. Press the flag. So now it gives us a reddish square. Yeah, so that's basically it for logo. Just an introduction to introduce it to people who may have never even heard of logo before. I think it's a good way to like teach people how to start programming, and you can write small programs with it, or just make drawings with it. Nice little drawing tool to try to teach programming. So I think it's cool. Recommend everybody check it out, give it a try. So anyway, that's going to wrap it up for August 2022. Appreciate everyone out there listening and watching, and I'll plan on being back in a month.